recording. Again, if this freezes up, just use the hand raise feature because I can't see the chat or speak into your mic. All right. Okay, so basically here, I might have started this last time. I don't remember, but that's okay, I guess. Basically, in this section 1.2, we're going to now look at quadratic equations. You know, in section 1.1, what we did last time, yes, we saw linear equations, but we also saw some terminology with equations in general. You know, like what a solution is, what does it mean to solve an equation, that kind of thing. We also saw the methods we can use to solve an equation. You know, you could simplify either side, add something to both sides, that kind of thing. With quadratic equations, all that applies. It's just that with quadratic equations, usually you have to do something else to solve the equation. You know, some other kind of method. And so that's where the factoring comes into play and the quadratic formula. Basically, those are two methods we can use to solve a quadratic equation. So we're gonna see an application of factoring. Namely, we can use factoring to solve a quadratic equation. I mean, the whole idea with factoring is very useful because what you're doing is you're taking a polynomial and you're breaking it up into more manageable pieces. I mean, yes, you can get the solutions to a quadratic equation. You can actually learn a lot about the polynomial itself. That's a different story. And we'll also see the quadratic formula. That's another method that you can use to solve a quadratic equation. I mean, you don't really get too much about the polynomial as you do from factoring, but the quadratic formula is nice. There are other methods in the textbook. One of them is, they call it the square root method. Another one is completing the square. You could also solve it using by graphing, but your answers may not be as exact as using these methods. Also, with completing the square, that's actually where the quadratic formula comes from. You know, in math, we like to prove statements that we make, things that we think are true, and the quadratic formula is no different. You know, it's not like someone just wrote it on the board and said, this is how we're going to solve, this formula will solve quadratic equations, no questions asked. You know, take it or leave it. You know, it's not like that. They proved it using completing the square. But for time consideration, I'm not going to do completing the square. So, all right, anyway, so we have that. So what is a quadratic equation? That's an equation that can be written like this. When I say can be written, I mean you can manipulate the equation you're given and end up with this. So you can add something to both sides, you can subtract something from both sides, you can interchange both sides, that kind of thing. Like what we saw in 1.1. So it's not like with a linear equation where you have b times x plus c essentially. Here you have a polynomial of degree 2 on the left side. Here we have a, b, and c. Those are numbers. A cannot be 0. If it is 0, then we're essentially back in 1.1. But we did that already. So also, this is what we call the standard form of a quadratic equation. When you have the polynomial of degree 2 equal to 0. Now, we saw with linear equations, there's only one solution, right? Well, there can only be one solution. You know, depending on the equation, you may have something that has no solutions. With a quadratic equation, you can only have at most 2 real solutions. You can only have at most 2 real solutions. You might have only one, and you might have none. That can happen. since we're not dealing with complex numbers, you can have a quadratic equation have no solutions. Okay, we might get the complex numbers, not in this section though. Maybe, I don't know when. I really want to try and do that one day, but we'll see. But for now, we're not doing complex numbers. Also, as I said before, there's different methods for solving such an equation, a quadratic one. The two we're going to do is factoring and the quadratic formula. All right, so let's dive right in. So we're going to demonstrate the method. We're going to deal with factoring first, and I'm going to demonstrate how you solve this by factoring. I mean, the whole idea, as you'll see, is you want to factor the polynomial as much as you can. You want to factor it until you can't factor no more, so to say. And then from each factor, you'll see you can get an easier equation or solution. Okay, so the left-hand side here, we have seen this one before. There's three terms. It's degree 2, and the leading coefficient is 1. So as I have here, we want two numbers whose product is 10 and whose sum is 7. And as I have on the screen, although I think we've seen this before, excuse me, as I have on the slide, the two numbers we can use are 5 and 2. 5 and 2, right? 5 times 2 is 10. 5 plus 2 is 7. So what do we get? We get this. So this is what we get. So by factoring, we have this here, right, is equal to x plus 5 times x plus 2. Now, since this here was equal to 0, we have this product equal to 0, as here. So really it boils down now to solving this equation. But notice how we have something easier to deal with, right? We have these two products here. Okay, now one of the important facts about multiplying numbers is that if you have a product equal to 0, then at least one of the factors has to be 0. So we have this product here equal to 0, right? So this has to equal 0, or this has to equal 0. They both could be, but at least one of them has to be. I think if I remember correctly, it's called the zero product property, I think it is, or the zero product rule. It's in the book. But that's what we can use, because from there, right, this is what I just said. And from there, to solve the equation, right, we want all numbers that satisfy this equation. So what we do then is we solve this and we solve this. We're looking for all numbers you can replace x by that make this equation true, because this equation is the same as this. That's what we just did. But now you can see how it's much easier, right? I mean, if you asked me to solve this directly or this, I would probably stick with this one. It's a lot easier. So that's what we're doing here. I also did email the notes, I'm sure you saw that already. So again, we're solving these equations, right? So what do you want to do? It's just like the last section, right? You want to get x all alone, and that's what I'm doing here. So we get x is negative 5. Here, excuse me, there we go, wrong button. Here, same idea, right? This is the other factor. As before, we want to get x all alone. So we get our x all alone. How do we do that? Again, we can subtract 2 from each side. We get x is negative 2, and so we get solutions. So in the quadratic equation on the previous slide, our first example, there are 2 solutions. And of course, it's good to check to make sure we didn't make a mistake. This is when x is -2. We plug it in for x. Yes, we do get 0. For -5 thing. So this is how we can actually solve. So this example demonstrates how we can solve a quadratic equation by factoring. Now, what exactly did we do? Well, so we are correct. What we actually did was this method. It was already in standard form, which means the right-hand side was equal to 0. And the left-hand side, you had the polynomial. We already had that. So 1 was kind of done for us. We factored the left-hand side as much as we could. Then we set each factor equal to 0, right? And by doing that, we set each factor equal to 0. And from each one of those factors, we can get another easier equation to solve. And of course, it's good to check. I mean, on an exam or quiz, if you did skip the checking, that would be okay, but it's really good to check if you can. Okay. All right. Let me pause here because I said